Hello, everyone, and welcome to today's session of the GMAT weekly videos. And in this session, let's look at what are the tips that you need to have to be able to comfortably handle inequality-based questions in the GMAT exam. So these are questions that can be challenging to students, but they are just a set of knowledge that if you have, you can comfortably address and tackle these kinds of questions. So we'll dive right into them and let's take a look at them. So questions are there. So the knowledge requirements which you'll have are basically, as you can see on the screen, we need to just know number types in manipulation because, and I'm assuming that you know what inequalities are. And in this case, these actually think x less than y or y, so on and so forth, or x greater than 0. Anything that has an inequality sign greater than or equal to, so on and so forth, that's what you need. So yeah, that is what we're talking about when it comes to inequalities. So these kinds of questions, they basically revolve around number properties, and also they do have some algebraic notation to them. So if you are good with the number properties and in its entirety and put that into consideration as you're approaching questions, you should be comfortable to address most of the questions you will come across. So look at them with examples. So first of all, before we get to the examples, what are these? What are we talking about? We're looking at integers. What are integers? Integers are any values that can be positive or negative, but they are whole numbers. So looking at -5, -2, -1, so on and so forth, 5, 7, 18, so on and so forth. Any whole numbers, these are integers, and the manipulations that come with them, all the operations. These will also include the prime numbers, even numbers, and anything which you may want to think of that is a whole number, and any operations that come with them. You need to know how to manipulate these ones. So that is one. Next, we need to know also fractions and their manipulation. So fractions and decimals will come into this. So one unique property about fractions and decimals that do come out when it comes to operations is that in their values is how their values do change in magnitude when you try to perform manipulations on them. And this one can probably let's talk of squares and square roots. Yeah. When you square a fraction, the value decreases. The square of a fraction is normally smaller than the fraction itself. For instance, a half squared is equal to 1/4, or also decimal as well. So 0.5 squared, 0.25. So they are actually becoming smaller and smaller. That's one unique thing about fractions, which should never leave your head anytime you're doing operations. So when you have this one in place, you should be good. At the same time, we're looking at squares and square roots. You need to know how to operate both for whole numbers and for fractions and decimals. That's actually one thing that also you're talking about that links the two of them. Yeah, that you can also be referring to. And algebraic notations, we do have x squared is greater than y. So what would x be? Or x squared is less than 1. What are we looking at? And these ones, the x and y can be any value, but then again, what the inequalities indicate do give you a pointer to what kind of number type you're dealing with. Either it can be fractional or integer or something else. Also, need to know how they relate among themselves. If you have all this knowledge at your fingertips, have all of them at your fingertips, you should be in a better position to be able to tackle these questions. Now, last but not least on this, once you've known all those properties, what you add when it comes to inequalities now is the operations part. You need to know as much as you can, as much as actually is required in the inequalities operations. For instance, -x is less than 5, or actually less than 5 or nothing. Let's say 5y. If you're to change this to x to be a whole number, if you divide both sides by x or by -1, it means the sign will change, the inequality sign will change. Yeah, so you'll have x is greater than -5y. Yeah, that is one thing which you'll also have. So normally the inequality signs do change when you do divide by negative number. That's one thing you should know. You can always subtract and add on both sides of inequalities without having to change without having to change the signs of the inequality, and so on and so forth. The modulus types of x is equal to x. Normally, you need to know all these operations are. Plus of x minus 5 or x less than what? Y plus 2 or modulus as well. We need to know what these do stand for. How do they, this can be either positive or negative or whatever is inside here. So you need to be able to comfortably be able to address these questions on their own for you to be able to be comfortable to address these questions. So it's easier said than done. And it's actually, as you can say so much, but comes to action, it could actually mean so much and may have so much detail. So we'll just take a look at a few questions just to try to point out these, and with practice and exposure to more of these kinds of questions, you'll be seeing them more and more as you prepare for a GMAT exam. So let's look at, for instance, this first question and see how that knowledge is applicable in this. Which of the following statement is equivalent to 8 plus 2x, which is less than 18 plus minus 6x, which is less than 23 plus 2x? So which of the following is equivalent? So to address these ones for this kind of inequalities, it mainly requires you first to reduce this to a simple notation. And also, look, if you look at the choices, we have them in decimal, fraction forms, and we only have just single value notations or expressions on each side of the inequality. We don't have the multiple values you do see in the questions term, in the multiple choices, which means you need to simplify this inequality expression to only a single value. And then once you simplify it, then now you can be able to see and compare how it operates, how actually this translates to the answer choices. So let's take a look at that. Do this basically to produce this, you have to just take them into chunks. That is 8 plus 2x plus 2x is less than, let me just I want to do this again. 8 plus 2x is less than, is actually less than 18 plus x. 18 minus 6, 18 plus 6x. So let's solve this one first. We can deal with the other part later. Because as they are, we can actually add and subtract without having to change an equality sign. So we can take 6x to the left-hand side and bring 8 to the right-hand side. So if you take 6 to the left-hand side, or actually add 6x to both sides, you'll have 8x. It's less than. And actually, if you subtract 8 from both sides, you'll have 10. So divide both sides by 2, just try to simplify it. What do we have? We do have 4x is less than 5. Since dividing by a positive integer, the inequality sign doesn't change, and x is less than 5 out of 4, because we can divide both sides by 4, which is a positive number, the inequality doesn't change. On the other end, also, we do have 18 minus 6x is less than 23 plus 2x. So as we had done on the previous expression, it can be the same here. So we can actually be able to add 6x to both sides and also subtract 18x, 18 from both sides. So we'll have, if actually not 18, but you can actually probably add, subtract 23 from both sides. So we have 18 minus 23 is less than what? 2x plus 6. So this will give us negative, this will give us negative 5. It's less than 2x plus 6x, that is 8x. To simplify both sides, actually have it as x, so you can actually probably do what? You can divide by 8 both sides, and since it's a positive, don't change the equality sign. So negative 5 over 8 is less than x. So we do have it simplified on both sides as actually we call as is expressed in multiple choices. The next thing is to bring them together. To bring them together now is just a logic. If x is less than 5 over 4, negative 5 over 8 is less than x. So we can have negative 5 over 8 is less than 5 over 4, so we can have it at the extreme end, where 8 is less than x, which is less than 5 over 4. So in this case, also you see that when you translate to the side, because x is less than 5 over 4, it just comes in that way, so directly. If you invert the expression and have x on the right-hand side, it will change to a greater than sign symbol. So anyway, that's not required for this question, but you can see just by simplifying it, by simple inequality operations, we are able to reduce it and solve our answer. And the answer choice that we see is choice C as our answer. So we're seeing in this question, we need just to understand the rules of operations of handling inequality questions. That's what you just need to solve this question.
You are watching Success with Bob Mwiti Show, presented to you by Upstack America. Upstack America is a consulting company that helps immigrants find amazing higher education and job opportunities in the tech industry in the United States. You can find our programs by going to www.upstakeamerica.com. Upstake America, we wake you up to the unlimited potential.
Let's go to the next question and see how it operates. Which of the following gives the complete range of values for which x factorial divided by y factorial is an integer? So this one, it requires you to know the properties that comes in place when you're talking about factorials, which can lead to the fraction or a fraction or a whole number or an integer. But actually they require you to have it as an integer. So it's also to know what factorials are, how do factorials operate. But your answer is not going to be the form of factorial, but actually the form of an inequality of a value which really satisfies the conditions given for this expression up here. So x factorial will be y factorial. You need to know that for this to be an integer, fraction operations is actually what you need to do. For this to be an integer, you need to have x must be greater than y. Yeah, that's the first condition you need to have. So x must be greater than y. Why? That is then and only then will you have the value greater than 1. See, like let's say 5 divided by 4 is 1.25. So 1 point at least. So, but then again, 4 divided by 2 is 2. So the numerator must be bigger than the denominator. So anything you have in the multiple choices that shows otherwise will actually not be an answer. Secondly, the next thing also we show that gives a complete range of everything. So what can we have? So for a complete range, that means this expression x factorial divided by y factorial should be at least 1, 2, 3, so on and so forth. Let's look at. For it to be 1, x must be equal to y. No, sorry, x must be equal to y. I'm not the other way around here. So the x must be equal to y. Yeah. So if x is equal to y, then you'll have it as 1 because x factorial by x factorial will give you 1. Yeah. So that's the condition. So an inequality sign of actually having an equal sign also will have to be it to be there. And so a combination of these two will give you that, give actually an integer which is the same. The rest will fall into place. For instance, if let's say if you're talking of 5 factorial divided by 4 factorial, that means 5 times 4 factorial by 4 factorial. These two will cancel, then you'll have 5, which is an integer as you're looking for it. Now, regardless of which value you take for x, as long as y is less than x and it's an integer, then you will have an integer as the answer. Now, so in the answer choices, you do have, let's see that what qualifies here for x being greater than y, and then also being at least equal to y, that is what answer choice B, as you have. We do have this one here, x equals to 0, as won't be there, yes, but why would this not be an answer? Simply because if x is equal to 0, then anything divided by 0 is undefined because we have a continuous increase in the y, but no change in x. So it will be undefined, so it won't be an integer. It's a value which is undefined. So knowing your properties operation by the integers and what factorials are and how an integer is formed by operations will help you answer this question. It looks simplistic but straightforward, but thinking of it and giving it some thought to it shows the difference. Now, here's a third question which you also can look at. If 0 is less than a, which is less than 1 over b, which is less than 1, then which of the following must be true? So this one, what does it show you? It shows you that we have 1 over b here. When to see 1 over b and you see the boundaries between 0 and 1, you're looking at either decimal or a fraction of the limit. So the properties of fractions do come in place, or decimals do come in place. So which of the following must be true? If you look at the answer choices, you're seeing that they are all, none of them has a fraction that they talk about. They're all either b, a squared, or b squared. That's what you're seeing here. So how will this operate? How will this operation be? So in short, we're being asked for what the relationship is between a and b, given the inequalities, if you square them. So which means that a is a fraction. That's one thing that you know. And then 1 over b being a fraction, then that means that b, well, if 1 over b, okay, well, 1 over b is a fraction. What this means is that b must be positive, greater than 0. It means b than 0. That means also B is an integer, or actually it could be a fraction or whatever it is, but B could be actually greater than 1. In this case, greater than 0, most likely greater than 1 in this case. So next is to find out how do these relate. If actually you have another B, a B, and then a B squared will relate to B. B squared will be greater than B because let's say for integers or any value greater than 1, if actually you square it, it's greater than the value itself. Yeah, for instance, let's say 5 over 4 squared, 25 over 16, which is bigger than what it was. This is greater than 5 over 4. Yeah. If you divide it and see, you'll see that this comes to the values that are locked into. So here's what we have in this case. For a fraction, if you square it, it becomes less than the value itself, the value that it was initially. Like let's say a half squared is a quarter, so a quarter less than half. So a squared is less than a. That's 1. Then you're seeing that b squared is greater than b. And you're seeing that also these ones, b in itself is actually greater than, is an integer, it's greater than 1, while a and a squared less than 1. So how will you arrange this in a logical increasing number? Like either now we see the choices are, the arrows are pointing towards one direction, they're all greater than signs. So we start with where we have b squared than b. This one greater than a, because a is actually less than 1. A is a fraction, so greater than a. And this a will be greater than its square. It's a squared, bigger than its square. So that is not the order that you have that must be true, not the sequence. So b squared greater than b, greater than a squared, which is answer choice E, the more. Yeah. So that is what you see. So unless you understand the relationship between these various types of operations, then actually it will be quite easy for you to address this question. That is it. Now, what will happen if it is a DS kind of question, data sufficiency kind of question? Now, let's see. We have been told that x minus y plus 1 is greater than x plus y minus 1. So, okay, is it actually being asked if it is x minus y plus 1 greater than x plus y minus 1? So, x minus y plus 1 is greater than x plus y minus 1. So, that's a question being asked. So normally with data sufficiency, the first thing is to analyze the question stem and be able to know the limits and what constitutes or what will constitute sufficiency. What will make a question sufficient or not sufficient, you need to know that. And once you do that, then you can go ahead and do what and assess the statements. So if at all you have x plus y, x minus y plus 1 will be greater than x, greater or less than x plus y minus 1. What will determine this statement to be sufficient? What will actually make this for you to be able to know if this is true or not true? That's what you're being asked. So this is a yes/no kind of question. So as you can see, we have x on both sides having the same sign. They're both positives. So we can cancel both sides. We can cancel them. So if you cancel them, we have negative y minus 1 or plus 1 being greater than y minus 1. So we can actually be able to collect the terms together, then we can address them and see. We can have y close to the left-hand side, that you can have it negative 2y being greater than negative 2. Because actually positive 1 crosses the side, not subtract 2, that is 8. So for us to have y as positive, then you divide both sides by negative 2, we'll have y being less than 1. Because divided by negative 2, the inequality sign changes. So y is less than 1. So if y is less than 1, then this will be greater than, then actually the equation can be answered as yes or no. If you can be able to find y being greater than 1 or less than 1 or greater than 1, then actually we can be able to determine what will be sufficient. So that is what we're looking for. So the value of x is not really determinant in this case, but y is the determinant. So here we see if x is greater than 0, the first statement is told. So x being greater than 0 doesn't tell us much about y in itself. We need to know what y is. So no matter what the value of x is, if it doesn't tell us what y is, then this is not sufficient in itself. That means that the cross of A and D. And therefore remaining the B, C, and E, the other answer choices. So we look at the second choice, the second statement. What does it say? Y is less than 0. If y is less than 0, that means if y is if y is less than 0, then y has to be less than 1. This condition is satisfied because negative 0.9, -1, -2. Whatever value it is, it will actually help us to be able to determine if it is sufficient or not. So y in itself, these second statements give us all the reasons, all the information we need to know about y to determine sufficiency. And therefore, this in itself is sufficient. Therefore, B alone is sufficient. 1 is not sufficient. Therefore, B becomes the answer. And that's where we stop our search. So we see that also in this question, for you to be able to address these, to assess these statements on their own, you need to know how to manipulate the inequality notations and in the algebraic context to be able to address and solve this answer. So that is basically it. So if you're able to know all this, as we had talked about at the very beginning, know how to manipulate number types, know how to not to manipulate fractions, squares and square roots, and algebraic operations that may be involved, and how these do relate, you can comfortably answer any question that is thrown at you on inequalities. So do more practice and find out more about this as you do practice, and look out for these aspects, and you will improve on your performance over time. So thank you for watching this video. I'll come back again next time and we shall learn more of these items. So in the meantime, bye. Have a good day, evening, or night. Bye.